Okay, recording now, and I got it. Let's see, 9/11/2019. This is ITSE 2347. We were discussing the last program, the program that I gave with the rock, paper, scissors, and what did I really want on that. What I'm looking for there is a procedure, and there was some question about what we had. Um, here is a procedure. This is one that a student wrote that would be acceptable. Create the procedure. It takes 1, 2, 3 output parameters. It takes 2 input parameters. Based on those input parameters, it updates one and only one of them. For example, if they're equal, it gives them a tie. If it's player 1 is the winner, it gives 1 a point. Otherwise, it gives 2 a point. And down here, it's just a print. Usually, we don't print inside of a procedure. So this would be an example. I gave you a cursor program that may have caused more confusion than anything. This is a perfectly good way to do it. This person simply hard-coded 1, 2, 3, 4, 5, 6%. I would have done 9. I would have done 10. Well, maybe 9, whatever. And to test it, rock, rock, rock. So I would have every possible combination. And demonstrated that it works by just coding them in there. And then this is what is output. So this person printed at the end of it, printed the code, and that's fine. That's fine. That meets the specification of the program. This particular program used a I gave you an example that used a cursor, but you didn't have to use the cursor. Let's see, am I getting through here? Some of you guys that are out there on Usenet internet land, talk to me. Somebody say hello. You guys hearing me?
Hello.
No?
Hello.
No, you're not hearing me. Yes, you are. Okay, that's fine. If one of you is, all of you are. Okay, now I wanted to start with today's stuff. And today we're going to start talking about our larger problem. This is called the rock, paper, scissors database game application. We're not going to really bother ourselves with a game. We're not trying to write a game. We're trying to write a database application. So I've got something that's running, and that something is generating transactions, and these transactions are causing data to happen, and we're capturing these data and recording what it was that happened in this game. As people play our rock, paper, scissors game all over the world, we are recording what is going on in this. Now, ideally, the project will have, this will become a programming project, and we're going to work on this for a while. Even though it sounds real simple, it isn't. I see it having 4 tables. I'm only going to talk about 3 of them right now. 3 tables. I'm going to bring in the 4th table later. There is a players table. I'm just going to call it players table. RPS players, or players, however I want to say it. A player has a unique identifier. A player has a date of creation. A player, I'm probably going to leave the name out for right now. I don't have to have it. I can go back and put it in later. I'm going to keep it nice and simple. I think I'm just going to stick with the 2 fields right now. The player has a unique player ID. So what is the player ID? A player ID is chosen by the player, and it's a unique identifier. So if one player has already chosen slasher, then slasher can't be used by somebody else. Okay. Let's see, a player ID, I don't have any other restrictions on it. I think I give it 16 characters. You're free to give it more If you want to have longer player IDs, you're free to do that. Some things that I would not do, I would not give the players numbers or anything like that. I would not use the player's real name like Sam and then try to match that later. That will confuse the things, at least right at first. At first, let's keep it simple, and then we might get it confused later. We'll have plenty to confuse it. Okay, we might put in a password. We might encrypt the password. There's lots of things we can do with it, but we don't have to do that. We don't have to have it to demonstrate how it works in this transaction processing. So I have a table. In the table goes players. A player has a player ID and a date on which the player was created. How's that sound? And then if you want to put in a real name, you're free to do that if you want to. Player has a name. Okay, that's fine. That's not important to me. Password. There may be other fields, maybe a password. We'll worry about that later. Games, the games table. Here's where it starts getting a little more complicated. The players table is the parent. The games table, a player has 0 or more games. A player is involved in a game. A game has a unique identifier assigned by a sequence. I'm going to talk about sequences right away. A game has a date of creation. So immediately when I create a game, I'm going to give it a number. Arbitrarily give it a number just from a counter. A date of creation. Grab the date from the computer, put it in there. Okay. A game will have 2 unique foreign keys referencing the players table. A game has 2 players. Both of the players have to be in the players table. That's what it means to be a foreign key. We're going to enforce a couple of other things on this because I've assigned this before. So I know what gives students trouble later down the road. We're going to enforce some things about this right up front. Number one, we're going to not allow there to be any duplicate games. So if Bob and Joe are in a game, then Bob and Joe can only be in one game. That means that if Bob and Joe are in a game, Joe and Bob can't be in a game. Well, that's fairly simple to enforce. We can do that. The other thing is I know no plays with Bob and Bob. Right? They have to be 2 different players. They have to be 2 unique players, and they have to be unique even in terms of the order. So Bob and Joe means no Joe and Bob. Okay. They can't be reversed. If we enforce that, it'll be a lot easier on us. Now, if they're unique and so the pair is unique and required, then they could be the primary key. They could be the primary key. The player 1, player 2 pair could be the primary key. I think I'm going to design it with a number, with a game number, game ID. But if I give you 2 players, if I give you Joe and Bob can only be in one game if they're in there at all. And if so, they have to be unique. Therefore, they would work as the primary key.
Joe can be in more than one game.
Joe can definitely be in more than one game, and Bob can be in more than one game. Joe and Bob just can't be in more than one game with each other. Because I said so. Because later down the road, we're going to come into a situation where I'm over in my web page, and we're gonna work this into a web page, and I've got Joe and Bob, and I have to find that unique game ID. If I can come back with 2 game IDs with Joe and Bob, and then another one for Bob and Joe, I won't know which one is which.
But you can reference the game with the game with the game they gave you. Yeah?
If I have a game and I have
Yeah.
two players,
Certa, whatever.
well, I have a game and Lana and Steven are in the game, then that can be the only game that has Juana and Steven in it in any order. And I can't have a game with Steven and Steven.
Okay.
Okay. So that's probably the biggest point of it, and I'm going to take care of that today. Rounds. A row in the rounds table represents one play by each player. A token is an individual play, R, P, or S. And if you want to throw in Wizard Spock, that's okay. You can rock, paper, scissors, Wizard Spock is another game that's pretty much the same. Sometimes students do that. A round has a unique identifier. A round has a date of creation. A round has a foreign key referencing the games table. So if I look at a round, I know which game it belongs to. So a round would be like rock, paper, and it belongs to one specific game. I can very easily pull up all of the rounds that belong to game 23. I can tell you who is involved in game 23. Now, what I'm not going to maintain in the database, I don't care who the winners are in the database. I can figure that out. I got a computer. It'll do that. Right now, I'm not worried about who the winners are. I mean, we'll probably worry about it at some point, but that's trivial. That's a silly little problem compared to keeping track of the data. And then I say, last but not least, we're going to have an error table for where anytime there is an error, that means whenever something goes wrong, we're going to write it to this table. But we're not going to do that right now. Right now, we're just going for 3 tables. Procedures, okay. Questions? Online people. I don't see anybody trying to chat. You guys with me online? This is in the, you'll find this file that I'm pointing to right now, this Word document under Part 1 RPS project. And let's see, that is in, okay. I need to move this Visual Basic part down. I don't know how it got stuck in there like that. The RPS project under Part 1 RPS project for 200 points is, this is what I'm talking about, and this file is part of this guy right here, and you can download, or you can get that Word file right there. Okay, now I will share this part with you. I recommend that we create several files. We break it into files, and I'm going to number them 1, 2, 3, 4, 5, because that's the order I'm going to execute them in. Otherwise, I'm going to get a very, very big file. And one thing about SQL code, and particularly this TSQL code, it will get long. And so we'll end up with a file that has 3,000 lines in it, and you won't be able to find what you want. So we're going to break it up into, the first one is the create tables. Go ahead. Okay. I'm going to create a database for me. I'm going to call that database RPSDB. I think that would be good. Keep them all together in one place. We're going to have a lot of different files in here. Okay. Now, I'm going to start off. Remember, what is my highest level? What's the parent of everything? Players. Players gets dropped last. The next one down is games, and the final child is rounds. Drop the rounds first, the games next, players last. Create the players. Fairly simple. Nothing to it. It has a primary key. It has a creation date. I put a not null constraint on that. I don't really need to worry about that because I'm going to put the date in there from the system. So every time I insert, I'm just going to automatically date stamp it. I don't have to add that. I don't have to do anything with that. I'll show you how that works here in just a second. So the user is going to select a username. So ultimately, at some level up there, it says, what is your username? And the user is going to type in, I want my username to be Santa Claus. And it checks to see, can it use Santa Claus? If it can, it says okay. If not, it says no, you have to choose another one. So the usual way. And what's that doing? It's running SQL behind the scenes. And so the user enters something, it checks to see if it's there. If everything's fine, it puts him in the database. Pretty simple. Games. Games is going to have more constraints. Now, Games has a game ID. Games has a date. Games has a player 1. Games has a player 2. Okay. 4 fields. I could have others. We could add some others in there, but I think that's will be enough. And the constraint is, well, it's got a primary key constraint. It's got a null date constraint. Again, I don't think we need to really worry about that one. I'm just going to kind of blow that one off and let the system handle it. It cannot have a null player 1 ID. It cannot have a null player 2 ID. Player 1 ID and player 2 ID together have to be unique in the database. This is the one right here. It is critical that we not let you come in backwards. Therefore, I'm going to enforce this constraint that player 1 ID has to be less than player 2 ID. It doesn't really matter whether I say less than or greater than. I'm just going to say they can't be the same. One of them has to always be less than or greater than the other. So let's see, if I had player Bob and Joe in there, well, Bob and Joe are in there. If I try to put Joe and Bob in there, that's not going to work because they're reversed order, but I could go in with my code and just flip them. But then the unique constraint would get me. Okay. So that enforces the fact that I can't have them in reverse order. Does that make sense? And then finally, the foreign key references. It says make sure that both of those players are in the players table.
Where are you controlling that if I have Bob, I cannot have, for example, Bob and Joe, and later on I can have Joe and Mark?
Oh, you can have Joe and Mark.
Oh, okay, so
that's fine.
Yeah, you can do different.
If you, yeah. If you have Joe and Bob, you just can't have Bob and Joe.
Okay, I understood initially that I could have only one person.
Yeah. If you put in Joe and Mark, they would get put into the database as Mark and Joe because Mark is less than Joe. And it'll take any characters you want to put in there, numbers, whatever. So you can have a number as your player ID if you want. And you can have spaces. Doesn't hurt anything. The rounds table. The rounds, I'm going to leave this one to you. The round has a round ID. The round has a GID that references the games table. The rounds has a P1 token that is R, P, or S. The rounds has a P2 token that is R, P, or S. So I know from this, if you ask me any questions about it, I can tell you just about anything. I can tell you, show me all of the games that Sarah has played. Show me all of the games that Juana has been the winner of. Okay, I go out and I count all the games. I find all the games that Juana is involved in, going through the games table. And then I go and get the rounds and figure out how many rounds she won. I mean, it's a little involved, but I can get all that information. That's what a database is for. That's what it really does well. Okay. So a database isn't afraid of that kind of a thing. I just have to be able to keep it straight. Okay, questions. Now I want to talk about a sequence. Okay. A sequence is take a number. Let me pull one of them up here. Sequence. It's this simple. Create sequence. Give it a name. As what is its return type? It's usually integer. Okay, but it could be character. Could be, I guess it could be varchar. I don't know. I've never done one as varchar. I've always used integer or long integer. Now think of it like take a number. Okay. So if you go to a busy meat counter at Central Market, anybody like to shop at Central Market? Nobody shops at Central Market. It's worth going. They have food from all over the world. If you go there anyway, a busy butcher counter or a busy bakery, they'll tell you to take a number. Two people cannot get the same number. Why? Because one will get there first and the other will be set after them. Okay. So if one person takes one, the next one will be 2 and 3 and 4 and 5. I don't care whether they're in order or not. It means nothing to me one way or the other. I have a way to say make them be in order or a way to say don't make them be in order. Basically, I'm going to keep going and going and going, and this is a really big one, but basically it says that two people will not get the same number. So if that is set up for the primary key, it makes a very good place to get a primary key. I like it better than a sequence, because if this guy is going up and up and up and up each time, I know that if I look at it, I know, and I need to put a primary key in there, I know what I can. I just go one more than the biggest one that's in there. Right? So it's coming from the sequence. So I take a number and then I put that number in as the primary key. I don't just let the table do it. I don't like, personally, I don't like identity or auto number, whatever, where the table numbers itself. I prefer to do it. Okay. And the sequence, what's the sequence name? Is game sequence, game SEQ. Okay, let me show you an input. Here is a test. This is just a little test routine. I'm going to take this out. But basically, I'm inserting into players, PID, PDate. What do I insert? I insert Phi, player named Phi, a player named Phi. This is how you insert the date. Get date. Boom. A couple of milliseconds later, the other one gets inserted. They probably won't be the same. If they are, I don't really care because I'm not using that as a primary key. It's just a timestamp. So I know about what time you were created. So I've inserted 2 players. Now I insert into games. The game ID. Okay, here is the sequence. Next value for game ID. Well, the next value will be 1 at the beginning. So that should put 1 in there. Next time I do that, I will get a 2. Next time a 3, and so on. I have full control over it. I can set it to 5 if I want to. I can take the next value and work with it without putting it into the table. So I have a lot more control over this than I do with anything else. So that's why I like it from a programming perspective. Get date, phi and phi. This is just a test. Now, if I want to run this as a test, I have to go to create tables. And if I execute, okay, it worked. I had something highlighted. Put them in there. And then I can execute in order. Okay, procedures. Now this is where we're going to be working mostly, right at the beginning. This is how we really use procedures in database. These are working procedures that you would find these guys out here writing this stuff. This is kind of what they spend their time writing. Most of the procedures that you'll write in database are not that complicated. They're not real logically difficult to understand, but there's some things you can do that will make your life a lot easier and your database's life a lot easier. Okay, what's this procedure going to do? Insert player. Sarah, you're going to have to do your if exist drop, and okay, since you have a earlier version of SQL Server, that's fine. It'll work. Just do it that way. Rest of us can do create or alter. If you have, you're looking at me like you're nuts. You okay? Okay. Everybody okay online? I don't see anybody yelling at me in the chat room. Okay. What's it got? The input. Now this is the part I want to see. This is really the part that I need to see. And then I'm going to look and does your code match this? What are the inputs? What is the input to this procedure that creates a player? 1. Well, actually there isn't a timestamp, is it? Is there? Yeah, I don't need to have that. What's the input? Just the player's name. That's all I need to put a player into the database one way or the other. Okay, what can happen? Everything can be fine. I don't need to worry about a null timestamp. I could have a null player ID, or I could have a duplicate player ID. Now, this is how they usually work. Most of the time, a TSQL, a transaction SQL procedure, does not report back to the user and say, error, error, danger, Will Robinson, danger. You know about danger, Will Robinson, danger, do you? No? It was a silly movie called Lost in Space, and they had a robot that ran around waving its arms and saying, danger, Will Robinson, danger. Which is kind of silly. But basically, it doesn't say cute things to you. It simply returns a number, and I call that number error level. If it comes back as 0, that means everything is fine. Everybody's happy. If it comes back anything else, I look at that value, and then from that, I decide what happened and what I should do about it. So this particular one, if error level comes back 0, what? Well, I think you're probably right. ERRLV, well, it's in a comment. LVL. Did I have a 1 in there? I won't see it in there because it's a comment. 1 is a null player ID, 2 is a duplicate player ID. Let's see, I don't need this one. So let me. So the first thing I'm going to do is I'm going to check to see if the player ID is null. Well, this is how I do it. Okay, so this is Stephen's method. I set it to 0 at the beginning. So I set the error level to 0. And then I proceed down through the logic. And then the first thing I check for the PID being null. If the PID is null, I change the error level to 0 and exit. Else, is it already there? Change that to 2. So check and see if that name is already in place. If it is in place, if it is already in use, I set the error level to 2 and exit. Well, hang on. Well, I've lost some code. I had all this code written. I don't know what I did with it. I don't have to do begin. If exists. If exists, the parentheses handle it. That's how you do if exists. And okay, else. And I had this written. I don't know what I did with it. Else. Insert into players. And let's see, what did I name it? I named it T. Insert T players because you have to have some kind of way. You have to do this. So you come up with a way, a naming convention that makes sense to you. I am naming my tables beginning with a T. So I want to be able to look at that and say, aha, that's a table. Why do I know it begins with a T? What makes sense to you? You're going to get a lot of things that you have to name. They're going to be different kinds of things. And if you can't look at a name and tell what kind of a thing it is, you're going to have problems. There's, well, was that a table, or was that a parameter, or was that a variable? Well, variables are easy. They begin with the at. But it's not always that simple. And you get lots of different levels of stuff, and you're going to have variables here. You're going to have variables over in the web page, and they're going to be talking to each other. And it can really turn into a monster of trying to figure out what the name goes where. Where is this name? So if I see it, that's why I'm very strict on naming things, because if I'm not, therein lies madness and folly, and I'm just going to be confused. So I want to try to give myself not room for confusion. Is that important, Mona? No, doesn't matter. Okay, insert into players. So in other words, I pass all of these tests. Insert into players, players what? I'm going to insert into players, let's see, PID, comma, P date, values. Okay, what values am I putting in there? Yeah, PID, but the PID is this is what's going in there. the input parameter. And the date. Well, what's the date? Get the date from the system. I don't have to pass it. It's just when I get there, it's got the date ready for me. Very handy. And I'm done.
This procedure is just only a new
Do what now?
that procedure is just only a new player.
Just to put a new player in. It checks everything. Now, let's test it. First thing is I execute it, and it created the procedure. And I guess I really should save it this time. Save all. I have another one over here called test somewhere. Here, RPS test. Oh, I know what I have two of them called create procedures. I knew I'd save that one. I have two files, one of them called create procedures, and there's my, it's already, oh well. Let me delete that last one. Let's see, I think I can delete this one. Okay, I'll name that 2_create procedures. And here's the test. Okay, I'm going to execute the procedure. Okay, I have to declare the variable for the output. So I have an integer, ERR. So this insert procedure, let's go back and take a look at him. Okay. Right, remember he takes two parameters. He takes the player name, PID. It's okay if they have the same name. One of them's got a @ sign, one of them doesn't. And he takes another one called ERRLVL. That's an output parameter. That's what he sets. He sets him like this. If he's a 0, if it comes back from this procedure 0, that's your signal, thumbs up. Everything's fine, no errors. If he comes back a 1 or a 2, he had either a null first parameter or a duplicate first parameter. It's already there. Why do I set him to 0 right up front? I don't know, because that's the way I do it. Is there another way to do it? Yeah, I'll talk about that maybe in just a second. Then I start off down there and I say if PID is null. Why did I do that one first? There was a reason I did that one first, as opposed to this one. Why did I do this one first and say that's better than the other one coming first? Okay, you are correct. Did you hear what Juana said? I don't have to go to a table to test that one. It's just either null or it's not. It's all right there in the variable. Is it null? If it's null, 1 is the error. Set it. I never even look at the rest of it. If I get past that one, then I have to go to the table and search the table. There's a reason. Okay, so, and let's see the test. So I'm going to try this one first. Well, I'm just going to go ahead and execute this whole file. Boom. And I don't know what the problem was here. P date, what's the problem? I don't know what the problem was. State 2 parameter. date. I thought, well, maybe I've got it up here. No, I don't. I guess maybe I need to run this one. And okay, I was running. I had one there that wasn't the correct file. Hey, that's the first time that's ever happened. Huh? Tell me about it. That happens all the time. Notice there that I got. Let's see, my. Okay. I'm going to create the procedure again. Let's see. Create my tables first, so I'm going to, oh. I should not be inserting stuff into my tables until I get there. Testing it is important. And testing it is probably the thing that you're going to have to do the most. The coding that we're going to do here is not particularly difficult. It's the testing of it. And then the interface and the interplay between all of them that becomes complicated. Okay, so I'm going to execute this guy. Everything's fine. And let's see. I'm going to create my procedures again. Execute. And now I'm going to run my test routines. I don't know why it's showing a squiggly red line under there. It's fine if it does. I don't worry about it. Execute. And notice that I'm good, 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 good. I have 4 goods. And then I have 2 errors. I have an error code 2 and an error code 1. So the first one is good. I inserted fee, first player, and then fi, and then fo, and then fum. And then I tried to insert fo again. He already exists. He came back with a 2. Then I tried to insert a null value. He already exists. He came back with a 1. Notice that I never got an error message from the database. The database never returned an error. This is the important part. No errors from the database. I'm controlling. I don't want to see errors from the database. If this is my first level of defense, is now the procedures. So I've put something between the world out there and my my database. Okay. And the idea being that we're going to set up a database and we're going to simulate something that is very valuable, something that people, the bad people, are going to want to break into. It might have personal information in it, it might have money in it, I don't know, but we're simulating this is valuable. We're creating these transactions. These transactions are coming all the time. It's like from Amazon. Okay, so people are buying stuff and the transactions are happening, and we have to keep our database available on the internet, but we still have to keep it back. And so what these procedures are doing is stopping people from touching the tables. I have to give you a way to put in a user, but I don't want to let you just insert into my tables. Does that make sense? So I don't let you see the tables, I let you execute that code. And basically I let your web server execute that code. So you come in on a web server and you have a button on your web server, and when you push that button, you put your username in a field there, you push the button, it sends it to that procedure executes, and something happens. It's either good or it's bad. If it's bad, it comes back to the web server with a 1 or a 2. If it's good, it comes back with a 0. If it comes back with a 0, the web server says, wonderful, everything's fine. If not, it tells you based on the 1 or the 2, what's wrong. Okay. So it's the web server that's doing the talking. Let's finish up here. Goodness, it's 7 o'clock already. Create tables. Okay, games. Games is going to get a little more tricky. Games has more constraints. Okay, let's go to the procedures. Create or alter procedure, insert game. What are the input parameters? What do I need to insert a game? This is going to be yours. Game ID, you don't need to worry about because you're going to get that from you're going to get that from the sequence. Let me show you how to do that. Right. The game ID looks something like this. This one is testing the game ID. So here's the insert. Insert into games. The game ID, but I don't need that as an input to my procedure. The procedure is going to get that from the sequence. So the procedure doesn't need to get the game date. What does the procedure need to get? Only. Okay. So the two player IDs. So that's really all I need. So what are the input parameters? What are the error codes? How will you do the error codes? It could be, I can think of different ways to do them. Will you have one error code that says, well, gee, there's something wrong here? Or will you have an error code that says, well, player 1 is bad, and a different error code if player 2 is bad? Maybe even a third error code if they're both bad? If they're the same? Okay, there's several, things that could be. If suppose that they are backwards. Suppose that player 1 comes in as Zoe and player 2 is Al. Clearly, player 1 is greater than player 2. You could switch them.
How did you get the game?
Huh?
How did you get the game ID?
Game ID comes from the sequence. Right here. This is, it's going to look just about like this. Let me copy this. So when you finish down here and you get to the end, it will look something like this. Okay. There's your player 1, player 2. Where did we get the game ID? It comes from right there. It comes from the sequence. So the first one is 1, the second one is 2, the third one is 3, and so on. Okay, let's see, we can do this one if you want.
So game is not really like, the thing is, I'm confused. Game is going to be like every time that they get to do the activity over there. It's not like, for example, I have Zelda, or I have Mario. That is not the game that I'm talking about.
Tell me again. Help me out one more time there.
Okay. We are talking just only.
Okay. I have 2 players. I have
just only one game. Rock, paper, scissors.
No, the game doesn't know about rock, paper, scissors yet. The game only knows the 2 players.
Okay.
So.
I'm sorry, I was thinking that we have different games that you can play.
Oh yeah. Oh, you mean a different game like rock, paper, scissors and Doom or something like that? No. The games are 2 players joined together, and we're playing So 2 players, me and thee, that's a game. If you're playing with someone else, that's another game. If I'm playing with someone else, that's another game. So I can be involved in any number of games, but only one game with one specific person. Yeah. No, we don't want to get too complicated here because it's going to get complicated enough. Okay, so what is this? Let's answer these questions. What are the input parameters? The 2 player IDs. What shall I call them? P1 ID. P1 ID was a char 16. Player 2 ID is also a char 16. Error level is an integer output. What should the error codes be? 0. Well, let's start with 0. 0 is okay. What is a 1? 1 is equal. Equal players. What is a 2? Duplicate game. Okay. And by the way, you're not set in stone on these, right? This is the way I'm approaching it. Okay, so I'm showing you how I would go about developing it. If you decide to do something different, you may. 2 is duplicate game. But I do want to see this documentation, this part that tells me what I'm going to get back from it. This is important. Okay, duplicate game, what else could go wrong? What about null? Let's see, the players have to be, so what else could I have? I could have null players. Either player. If you wanted just to say, just give it one code for either player being null, that would be acceptable. You know, this one's going to get a little long. Okay. Duplicate game means that there is already, I'm trying to put in a game with Al and George, and Al and George already have a game. Let's see, duplicate game. So Al and George already have a game. Duplicate players means I'm trying to put in a player with Al and Al, the game with Al and Al, where Al is, both players are the same. Okay, equal players. That means that both parameters are the same. I don't want to allow that, because then I don't know who to make the winner. I mean, if Stephen and Stephen are playing and boom, 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 I won. Well, who gets the point? You know, now we got a problem there. So I'm trying to avoid those problems. The other one is that if I don't want to allow reverse games for that same reason, because then it would be just as bad. I don't want to allow duplicate games or reverse duplicate games. Let's see, invalid players. and I'm going to put S, meaning it might be one or both. Okay. In other words, now I've got to go check the players table and make sure that they're there. So that's the if exists or if not exists. If not exists, player A, or not exists player B. I could do it with an or. Boom. Give them that one. So let's see. Equal players is an error. Duplicate game is an error. Either player being null is an error. Either player not existing in the players table is an error. What about order of players? What about player order? Okay. But I don't have any way to do that easily in the SQL. I can do it, but I have to check it both ways. Okay. So the easiest thing to do is to say if player one, well, if player two is greater than player one, swap them. So wait a minute. Swap them. So I would do this. I would set it to 0, and then I would check this one right there. I would say, is one of them bigger than the other one? No, I'm maybe not right there. Are they equal? And then if they're not equal, I would check them, and if they're in the wrong order, I would reverse them.
I think I do it in duplicate game, no?
Well, I need to have them reversed to check for duplicate game. So once I have them in the right order, I can check for duplicate game. Okay. Then I check the players table to make sure they exist in the players table. And if so,
For example, let me ask you.
Okay.
That is logic. For example, if we went to number 1, that it was the same, something like that. You have number. So in conclusion, can we have different number for one thing, for one record or one string?
You have control over how you want to number your errors. You may control how you want to do it. I would suggest trying to keep it simple. So I would simply do one number for if either of them were null, I would just return one number. So if check to see if I would say if player 1 is null or player 2 is null, that's a number.
Yeah. For example, what I was thinking is in some situation over there, you could return 1, 2, and 3. But if you return 1, 2, and 3 for the person that is receiving the information, they already know what they need to do to go through.
Okay.
And I don't think that is a good thing.
I'm not sure what you mean.
Okay. For example, let's go in a bank.
Okay.
I'm going to give the answer that the name that gave me is not the right name.
The name they gave you is not the right name. Why isn't the name the right name?
Okay. For example, because I checked in the name in the check. If not, I don't have it in the database or whatever.
Okay, wait. Let's stick with this one.
Okay.
You're gonna give. I'm gonna give you a username, Steven. How could that be wrong? It could already be there. Okay.
But probably doesn't match within another person.
Well, if it matches with another person, it's invalid.
Okay.
That means that you're going to come back with an error message.
Okay, but my question is, can you return different message, wrong message, or you could be nice just only to answer one?
Just keep it simple. This is what you call ladder logic. The ladder logic starts down through it and it says, is it this one? If so, it returns a 1. Is it this one? If it is, it's a 2. Is it this one? It's a 3. Is it this one? It's a 4. And then if it gets to the end and doesn't get any of them, well, it was set to 0 at the beginning, so the 0 is what comes back. Now, there's another way of thinking about it, is that you go down through it, and at the very end, you say, okay, else set it to 0. It's just a different way of programming. So you check it for the 1. If 1 set it to 1, else set it to 2, else set it to 3, else set it to 0 at the end. Just different ways of thinking about the same thing. They're both equally valid. One of them says you fall out of the ladder and set it, and the other one says you just fall out of the ladder and it's already set. It's one, and the way I do it, the way I have mine working, I set mine to 0 at the beginning. I'm what they call an optimist. I say it's probably going to stay 0, and then I go down and check, is there anything wrong with it, right? The other way is you could have a begin here, else you do your insert, and then you set the value to 0 at the end, the pessimistic approach. Either way is perfectly good. I would do it one way and stick with that, whichever way you like. Do you see what I'm saying?
Show me please the last one that you were creating code.
Well, I'm sort of creating the code. The idea here is, or the error codes, player order. Okay, what are the error codes? I would do them in this order, okay? So 0 is the default. In other words, if it's okay. If I don't find anything else, it's going to return a 0. Then is either player null? That's easy to check. That's a simple if A or B. If A is null or B is null, kick it out. It could be a 1, for example. You can make it anything you want. Then I would say, are the players the same? Is player 1 equal to player 2? That's a 2. Kick it out. Okay, you're done. Else, I would look at the player order. Am I in order for the players? Are they in? Is player 1 less than player 2? If not, I'm going to swap them. Okay. Then after I check for swapping them, I check for a duplicate game. After I've swapped them, so now I know they're in the correct order. Now I can look for a duplicate game. If they were out of order, I wouldn't find the duplicate game. Okay. Then I check for invalid players because both of these last two involve I have to hit the database. So I see 0. I see 1, 2, 3, 4. You could do more than that. You could have more error codes than that. You could have an error code for bad player 1, error code for bad player 2, if you wanted to. You don't have to do that though. Okay. Basically, you're just going down through it. You just crunch through it, and when you get to the end, if you get to the end and you haven't hit something, then it looks like this. That's your insert at the end. See if he executes. Must declare, no, sorry. There. You have to make sure you don't have anything highlighted. Okay. Let's go down and take a quick look at the last one. Insert game. Okay, insert round. I'm going to let you do that one. Insert round. What are the parameters to inserting a round? What do I need? Okay, I'm going to tell you a little bit more about inserting the round. Let's see if we can finish off the insert game. So, and then we test it. So write the insert game and test it. Now, when we get to insert round, and I need to write this up for you, what do I need to insert a round? A round is a round. Okay, so here's here's players. We're players. So this is the players database. Me, you, Sarah, everybody. 1, 2, 3, 4, 5 of us here. So we can have what, 5 factorial games. Now we have a game. Sarah and I have a game. There's 2 games. A game has a round. Ready? Do, boom. And then you play something. You can't look. Okay, that's a round. So this is S. I play S, and you play. Well, you know it now, so you can play R for rock, right? Okay, so that's a round. So I play S, you play rock. A round is associated with a game. So that round belongs to a game. A game has 2 players. So as I follow it up, I can follow it from the game. I can tell you to which game it belongs. From the game, I can tell you the 2 players that it belongs to. Now, what do I need to insert a round? Think about this. What?
You need the game.
The game ID.
The game ID that is go with date.
Okay. The date, I'm just going to date stamp it. Okay.
Play 1 and player 2.
So player 1 and player 2. Now think about that. And of course they're what they did was it scissors or paper or rock. So I need player 1, what player 1's play was, player 2, what player 2's play was, and now here's where it gets important that we not have any duplicates. What do I really need to insert? Because if you think about it, in the rounds table, I don't have the players in the rounds table. Go back and look at the Word document. Rounds, what is in the round? A round table has a unique identifier, comes from the sequence. By the way, you can just use one sequence for all of them, or you can have an individual sequence. It really doesn't make any difference. Makes it a little simpler just to use one. It really doesn't make any difference because I don't care what the game ID is. I don't care if my game ID is a 5 and then later it's a 23. It doesn't bother me a bit. A round has a date of creation. A round has a foreign key referencing the game's table. In other words, it's got a game ID. And a round has 2 game tokens representing the play by each player. But where are the players? The player, where? Are you with me? The players are up in the games. The players' IDs are in the games table. I'm trying to insert a round. Now here's where it gets a little tricky, and I'll give you some help on this. I've got to get the game ID using the 2 players. But because we set this up with the players being unique and ordered, so if I have 2 players, Bob and Joe, that can only be at most 1 game ID. Okay, we're not going to try to do that one for next class period. Next class period, what I would like to get, and it's time for a break if at best, worst, I'd like to get the games procedure finished. Okay, so build the tables and build and test 2 procedures. The procedure to insert the player, well, I've already written that one for you, and finish the procedure to insert the game, a game. Test it, make sure it's returning to you. You can print if you want to print from it so you can see it better. But when we finish, you're going to take the printing out. So it's going to be a quiet procedure. It's going to run quietly. It's just going to return a value to you. Okay. Now the games is fairly simple. The games is probably one of the more complicated. The games, because it has two foreign keys. The foreign keys aren't matched with the names because I've got 2 foreign keys. Well, they can't be the same as they can't both be the same. So I have to rename them. The rounds is going to be the most complicated because the rounds I'm going to have to decide. Will I pass it? Will you pass it the game ID? In which case, at some point, you have to go look up the game ID. Well, somehow you have to get the game ID. Now, the problem is that the 2 players who are doing this, okay, we're playing, well, what's my name? My name's Steven, and we're playing, okay, Sarah, so I know I'm Steven, boom, boom. I don't know that I'm player 1. You know that you're playing, you know what you play, but you don't know whether you're player 1, and neither of us know our game ID. But we have to get the game ID to insert the round. And that's, I think, for next time. Sufficient unto the day is the evil thereof. Okay, so we're going to wrap up there. I think that's plenty for one night.
So you want us to have the table build
I want you to build three tables, but I've given most of them to you. Yeah. What?
Yeah, I
What?
was.
Okay, 3 tables. You may add stuff to them if you want to. Take mine as being minimal. If you add like a password or something, you may do that, and we might do that later. We can always add to it. So the simplest is just we have a procedure that inserts players. We have a procedure that inserts a game. And that's pretty straightforward. And then the inserting the round is going to get a little more complicated. But once we get those guys together and running, then we can do some other stuff with it. Okay. Question coming in?
Yes. Are we doing things like the error checking for, let's say one player enters something and then the other player doesn't enter anything? Or are we setting a timeout so that because then the round tuple or row won't be complete. Let's say one person just quit.
Okay, yeah. We are not at that point yet. That would be something that the web page would have to handle. So at the point where we are now, somebody on the web page has already entered the stuff and they press the button that says, okay, play the round. or play the, create the game. And the web page would be responsible for, would check first that that one of them wasn't null, and it wouldn't bother sending it to the database if it obviously was bad. The database is only responsible for checking the what it gets, and right now there is no timer working on it. Basically, this is creating a game is going to look like executing a procedure. So creating a round, so playing a round might look like executing and insert rounds. And the database really doesn't care who the winner of the round is. The database is just taking the data and it's putting it in there. Now it's going to check to make sure that they're all R, P, or S, that nobody gets to put in G for gun or K for karate in there, right? So it's either R, P, or S, so it can check that. It can check to see that they're not null. So when you execute that, they can't be null. But there is no clock, there's no real-time clock yet running on it. Now we can put one on it. We can also, there's a number of things we can do depending on how ambitious we get. We can break it into 2 different game web pages. So we could have 2 people playing on 2 different computers. That's a little tougher to do, but it is certainly doable. But that clock has to come in from the web page, because it's the web page that creates the game simulation of it, the idea that there's a winner and a loser. At the database level, I don't have anything in, if you look at the database, there's nothing stored in the database that says who won the game. Now the plays are stored, so from the plays I can determine who won the game. And that's all I have. Did I answer your question? Who's speaking?
Tracy, yes, thank you.
Tracy. Uh-huh. And wait a minute, somebody's chatting here. Chris. Is that first validation necessary?
Oh, you don't have to answer that. You already did with your example. I was thinking when you pass parameters into the store procedure, you have to have them there if you define them, but they can't be null is what you demonstrated as the value, and that's what you were checking for.
Right.
So.
When you pass a parameter into the procedure, it doesn't check much. It just checks, is something there? And null, gotcha. Well, null is something, I guess, and if there's nothing stopping you from passing a null to the procedure, except if the procedure stops it.
Gotcha. Okay, thank you.
Mm-hmm. And let's see, code like exit and quit and the like from being used as a name, right? That would go to the idea of SQL injection. Where did you get the, let's see, who is that? I don't know who that
Tracy.
was. Tracy. Where did you get the exit and quit?
In meaning when you enter a name.
Okay.
Last week we talked about,
right,
preventing
SQL
injection.
Yeah, we're not going to, because of the nature of a procedure, procedures are not vulnerable to SQL injection, which is why we use them. The procedure just takes whatever you give it. So if you want to be named exit, that's fine. If you want to be named delete from, drop table Tracy, you're welcome to be named that. It doesn't hurt me because I'm never going to submit that string to the database for processing as dynamic SQL. And that is something that we're always worried about from as we start developing our web page interface. We're going to start worrying about stuff like that. Can people give us something that causes our database to barf? Right now, they can't because it's going into the procedure, and the procedure acts as a giant, preprocessor. Go ahead.
Nothing.
Okay, so the procedure will just simply put it into the table. I don't have to worry. I'm not executing code. I'm not putting it in. I'm not running an insert statement by putting your input into the statement. Okay, so let me pull it up here and show you this. This guy right here, I am not executing this with your code in here being pasted in there. It's coming into the procedure. It's coming into the compiled procedure, and it's getting put there by the procedure. I'm not saying, okay, execute this and put your code that you sent me, whatever it is, in there, and allow you to send me something like drop table students. You know, that can't happen here. I did need to talk about that SQL injection, but remember how it worked. I had to execute this, so I had to build a string out of this and then send that to my database. And that is considered just very, very dangerous. That's like, I'm not going to say what it's like. It's like unsafe practices. We don't do those.
Thank you. I'd kind of forgotten it.
Well,
Yeah, gotcha.
Right. So this is something different. This is safe. And anything that I write in here is once it's in that compiled procedure, it is very difficult for you or anybody to get in there and change it. And that's the whole idea. I've got this safety net built around me, and I'm not going to let you see this code. I'm not going to let you see my tables. I'm only going to let you see these procedures, and I'm going to give you those names, and that you can execute them. I'm going to give them to your web page, and they're coded into your web page, so you can see the name of the procedure if you look at your web page, and you can see the order of the parameters, but that's all you can see. You can't see the tables. You can't see the table names. You can't see anything about them. But you're allowed to execute these procedures, and that's all I'm going to give you. So the whole name of the game here is push the public back out of the database. I don't want you executing. I don't want anybody coming in and executing this code. The only way you're going to get to that code is by executing this procedure, and I let you execute this procedure, but I'm not going to let you see the table. I say, okay, it's okay to execute this procedure because I have control over that procedure. And that's what gives me the safety. And we're going to build other layers of security into it. This is our first layer right now, and we're going to, as we go out, we're going to build out like an onion. More and more and more. Until you're so sick of security. Boy, we're going to be safe. Okay. Questions? Okay, I'm going to wrap up there for the night. And I'm going to see, there's still one chat. Did I get everybody's chat? Okay, from your examples, we didn't use try, catch, throw for the validation. Try, catch, we will do try, catch in there. Right now, we don't. You can do try, catch in there. I'm keeping it fairly simple. There are no errors being thrown. Okay, my database, the way I have designed this code, well, let me go up here and look at it. The way I have designed this code for insert player, I have designed it where it is not possible to throw an error, I hope. I'm saying that you can't throw an error. No matter what you give me, I won't hit an error. I'm just going to deal with it in my code. You use try catch when you might have an error. For example, I might use try catch here to say to check, you know, to try to do an insert. So I might say insert into the player's PID date, but I might have an error there because the PID might already exist. In that case, the try catch would work. So I could use it here, and I just didn't get to that tonight. So, but I could put this inside of a try catch. And instead of using if then else logic, I could use a try catch and try it, and then as I catch the error, I put in the error codes that are returned. And that would accomplish the same thing. I'm just doing it with if then else for right now, but I will probably do the try catch later. Who was that? Mr. Misk, did I answer your question? Usually you use the try catch in place of the if then else logic.
Yes,
So
I'm sorry. I couldn't find the mute. Yeah, you did. I was just wondering, as a matter of style, or not in this place, or
it is a matter of
curious.
style.
Okay.
Which one you use, it's kind of like different people, different strokes for different folks, and try catch is certainly something you could use instead of the if then else logic, and it is not inferior to it and it's not necessarily superior to it. It's just a different way of accomplishing the same thing, because in a try catch block you don't throw an error either, it handles the errors. So essentially you do provoke an error, but you catch the error and your code handles it instead of throwing a big red glob across the page.
Okay.
Next week I'll have an example of that as a try catch. I think it'd be good to do one that way, just to see it.
Okay, thank you. Have a good evening.
Okay, I'm gonna wrap it up there, and like I say, I'm not leaving, but I'm gonna turn off the, yes ma'am. Bye. Okay. You have a question? Is it a question I should record or a question that? Okay, if I come up with any important questions, everybody's question is important, I'll turn the record back on. Until then, I'm going to turn off the recorder.